Okay, we are still in the standard library, and we're still covering things that are picked up in standard.io.h, stdio.h. Remember, you have to do a pound include of that at the top of your C program. You have to do a pound include of the standard.io.h at the top of your program if you're going to use any of these things. You can use printf, fprintf, and some of these that we've seen so far, but you may get some compiler warnings about redefinition and incorrect types and things like that. So you're always just better off doing a pound include of standard.io.h at the top of every useful C program, because it will get all of those definitions correct for you, and then cut down a lot on your compiler warnings so you can concentrate on your errors that you have in your code. Let's take a look at some formatted output. And we've seen these, but there's some variations on them. We've used printf a lot in our programs through the video series here. And you remember how the format works. It's a percent %s for a string or percent %d for a decimal and so on. And then you have a variable number of values which has to match to the items that were in the format string. Well, there's also fprintf or file printf, and that works exactly the same way as printf, but it has a file pointer as the first parameter, then the format string, and then the values. And obviously the values will be put into the format string to look like they would in a printf, and then the whole thing will be packed off out this file pointer wherever it happens to go. A printf is just an fprintf pointing to the standard out. That's all that really happens when you make that call. Here's an sprintf, and that's a string printf. What that's going to do is take the format string and the values, tack the values into the format string, put them into the buffer. And this string has to be big enough to hold this format with all of the data in it and an extra null at the end. So that's going to be a pointer to a character array, a string buffer basically, so that sprintf can put information into it. vprintf is similar to these, except it takes the format and the values, and it takes an arguments member that has already been created under va start. Remember the va start, and that would give you a va arg when we had variable length argument lists and functions? Well, this vprintf expects to get that argument set up after you've done a va start at the top of your function. It's basically taking that step out of printf and giving it to you, letting you do a va start and getting the argument structure right, and then handing off into the rest of the code underneath printf. So that's a vprintf or variable printf. Formatted input, we saw scanf, and scanf takes a format string, %s, %d, so on, whatever it's going to be reading in from standard in, and it assigns the replacement values that it's reading in into these variables. Now, I put an ampersand here because these all have to be pointers. We have to provide pointers, addresses of the variables, not just the variables themselves, because those would be the values of the variables. We don't care what the values currently are of those variables. We want where they are, because scanf is going to read information from standard in, reformat it according to the format string, and place it into those variable locations. fscanf does the same thing using a file pointer instead of the standard in, and scanf reads a string, reformats it according to the format string, or plucks things out of it and puts those little items into these particular variables. There's also character input and output, that after we have a file open or we're going against standard in and out, here we have fgetC from a file pointer, gets a single character. fgets will read a string from the standard in into a buffer up to this many characters, and fgets reads from a file. Normal just gets down here reads from the standard in. fgets uses a file pointer. So fgets reads a string from the file pointer and up to this size, puts it into buffer, and also returns a pointer to the same buffer. These addresses that we pass this one in and get the same thing back. It's just for some assignment capability. fputC does a file put character. It returns us back the character that it writes. We give it the character to write and where to write it, the file pointer to put a character to. fputs takes a string buffer, writes it out to a file pointer, and returns an integer of how many characters it wrote. put S. C equals getChar with no parameters is exactly the same as C equals getC from the standard in. These two are identical. You can use either one you like, or you can use getC on a different file pointer and pick up a character at a time from another file that you've opened. GetS of a buffer is like an fgetS, but it reads from the standard in. Takes in a string of data, characters mostly, of course, it's supposed to be a string, puts those characters into the buffer, returns the same pointer to that buffer. PutChar with no parameter is the same as PutC to, that should be to the standard out. That's a little typo right there. That's PutC to the standard out, so that PutC will return the character that it writes. PutS goes to standard out, and it returns the number of characters that it writes from the string that is in buffer to standard out. UngetC allows us to put one character back on the file pointer, so we can read and read and read many characters from this file, and when we get to a marker, we don't want to actually read the marker. We can do an ungetC and put it back. Put the marker back on the file pointer, go off and do other processing, and the next read that we get will pick the marker back up. So we're allowed to put one character only back onto the file pointer. So that's character input and output and formatted input and output of the standard IO.H. And we have one more video on standard IO. That's coming up next.